Hi everyone. Welcome back to CSCI 100 Lecture 24. This lecture is going to focus on a large new topic called classes, and more broadly, a new design paradigm, a new kind of computational thinking called object-oriented programming. And across this lecture and lecture 25, we're going to learn what a class is made up of and how we use classes and what an object is. Let's start off talking about classes. So far, we've had a wide range of tools that we can use when we're working with data and representing data in our programs. So as you kind of look down this list, think to yourself, what would we use to represent a whole number? Well, probably we'd use an integer or a rational number. Rational numbers can be represented with floats, so we have a decimal point. Maybe a collection or a series of characters we know as a string. For binary true or false, we've learned about booleans. And then beyond just those very basic core building blocks, we've also learned about some data structures like lists when we need an ordered collection of items. Sometimes we want an ordered collection of items that's immutable, and for that we can use a tuple. In cases where we want some sort of mapping from a key to a value, so a collection of key value pairs, we use a dictionary. We also learned about sets in cases where we want an unordered collection of items, no duplicates. And so for a lot of many arbitrary problems that we've come up with, we've been able to find a way to map one of these types onto to fit the data that we're trying to work with and take advantage of their nice properties. This has worked pretty well, and examples of applications that we've talked about names and money and counts. You can represent a class roster with a list, or like a seating chart with a two-dimensional list, or an image with a two-dimensional list of pixels. But what if we want to represent something more complicated? Or just a more complicated thing that we can't really figure out a way to map one of our existing data types to. How do we go about finding a type to use in that scenario? Well, let's pretend and let's go through this exercise of coming up with some way to represent a character in a role-playing game. So we're gonna make think through a role-playing game. We've got these three cool characters here. One has an axe, one has this like slashing thing, and another has some sort of, I don't even know what that is, a gold pickaxe or something. Maybe just fists, actually. Oh yeah, I see a little pickaxe. So in our game, what properties do our characters have? Well, our characters in this game will probably need some sort of health. It looks like they're able to attack people. So if they're able to attack, they probably need an attack strength. They'll probably need to be able to resist being attacked, and so they'll have a defense. And then, yes, of course, health to keep track of how they're doing, how much life they have. One way we right now could think about storing this information is in some sort of dictionary. We could come up with a dictionary that maps each character's name to their strength, a different dictionary that maps each character's name to their health, and a different dictionary that maps each character's name to their defense. Or maybe we could reorient that and come up with a way to have a particular character dictionary that then maps from health to their health, from attack strength to their strength, and from defense to their whatever their defense value is. But this is exactly what Python provides classes for. When we want to put together effectively a custom type. So before, maybe we'd like use open brackets to create a list, or actually call the list function, for example, to create a list. Here, we're going to create a character and pass in the name, the strength level, and the defense level. And now this character, we can access these different values associated with our character, or attributes as we will learn to call them, with this dot strength, woody.strength, woody.health, woody.name, and woody.defense. And I'm calling him Woody, just he kind of looks like a lumberjack. He has an axe. And the beard makes me think lumberjack. And notice here, something else we can kind of do with these classes when we're using them is call functions that are tied to the class. So Woody.introduce will actually print out, hi, my name is Woody, specifically because we named our character Woody. And I'll point out one more thing here in this use case. You can see I didn't pass in the health. And so when we set up this character, whatever is going on under the hood in Python, and we'll see in a minute what exactly that is, it just sets a default health of 100. So this is how we use classes.